Great, and we are live. I'd like to thank everyone for joining me in the open room today. I'm very excited for this session because I totally believe that 3D is the future of mapping. We've gone from 3D to a 2D map back to a 3D map. So I'm really pleased with that. I'd just like to introduce everyone who's in the room. And remind you that if you'd like to be part of the panel or jump into the room, I'd like to thank everyone for joining me in the open room today. I'm very excited for this session because I totally believe that having a little bit of feedback there. We've gone from 3D to a 2D map back to a 3D map.
I think someone has YouTube on.
Yeah, someone just has the. I'd just like to introduce everyone who's in the room.
I think it's closed.
Awesome, thank you. So I'll introduce you to everyone in the room. So first we have Hans van der Kwast with us. He'll be showing us one of the really cool 3D maps that he made for the 30-day map challenge. We also have Klaus, who's with us and will also be showing us a very cool 3D map. And Victoria and I are here on the panel to ask all the questions. Please put your questions into the comment section. I will ask whatever's going on and any sort of harebrained thing that comes into my mind. So I would like to hand over first to Klaus, who's going to take us through making a simple 3D map in QGIS. And please enjoy.
Yeah, I'm sorry about the sound. I had YouTube in the background in a browser I didn't use. So I'm sorry about that.
No problem.
I will be showing how or at least I will try to show how I created my hexagonal 3D map of Iceland in QGIS. So let me see if I can turn on my screen sharing.
There we go. Perfect. I can see it.
Yeah. And I will hide that one. And first of all, this is the third computer I'm trying this on. So bear with me. And I have to scale this up so it may look a bit weird in the interface. But anyway, the only data I used for this is elevation data. So let me grab some elevation data, and I have this GMTED 2010, and I've packaged that in a GeoPackage, so I have the global coverage. Really nice to have available at a moment's notice. And the projection for this is it's unprojected. So first of all, I need to put some better projection for it, and UTM zone 27 seems to work. Here we go, Iceland. We'll just fix the styling a bit. And like that. If you haven't seen my my posting for the 30-day challenge, never mind, you will see it in the end, hopefully, if everything goes. But it was hexagonal shapes extruded from ground level that represent that each shape's elevation. And all of that was cut in a hexagonal shape. So I'll start by defining the overall hexagonal shape. And for that, I will need a hexagonal polygon. So let me grab the grid, create grid function, and I will switch to hexagonal. The extent, I will try map canvas. And I need to know how big this should be. So I need to measure it. And it's 600 kilometers should be good enough. So let's make it 600 kilometers. Let's try to run it. Worked. Yay. And I only need one of them. So let me get rid of the rest. Like that. And move it. So it just covers my area of interest. Oops. Something like that. And I want to rename that to big hex. Then I want to have my smaller hex, those that actually protrude and extrude from the map, representing the elevation. So that will be a new grid. Grid. And since my last one was 600 kilometers, I think I can go with 20 kilometers or 10 kilometers maybe. Grid extent, map canvas. Let's try 10 kilometers. That looks okay. Place it underneath. Let's make it.
I love how much it looks like honeycomb.
Yeah, it really does. Next step will be to select the small shapes that I want to keep and remove everything else. And if you look along the boundary, you see where the selection will be. So I found that it's easier to try and move this polygon to a place where it will look nice-ish, at least.
Is that so that there are no sort of like weird quarter bits, so that it all kind of looks even?
Yeah, you will see in the corners which small hex will be included.
Okay.
You can play with this a lot, but I will not do that now. And when you have your big one and your small ones, you use this select by location, and you select from the small grid, and that intersect with the big one. And now you see what I mean. We have two side by side here, single one, 3 here. So if you're picky, you can play with the placement and you can edit the number of polygons that you select in the end. But I will keep it like this. And the small one, I will invert that selection. And we need to go into edit mode and delete them like that. I can close this one. And now I have my polygons that I want to use. The next step will be to, in order to extrude them, I need to have a value in the attribute table. And I will collect that from the raster layer. And there's a nifty little processing tool for that. It's called zonal statistics. The first time I did this, I used expressions. But then I had a problem that the raster layer was unprojected and my newly created polygons were projected. And then I need to transform in order to sample the raster values, and I only could do it in the centroid. And problems. This was much easier. So just
that sounds like a lot of issues.
Yeah, this is much easier. So just make sure you have your grid, the small ones, selected as input layer, your raster layer as a raster layer, and you see here they are projection aware. So this will work without any conversions. My raster only has one band for the elevation, and that I guess that's usual, but you may want to symbolize him with other types of rasters. Anyway, you can select what you want to include in the attribute table. So I don't care about the counts or the sums. I'm interested in the mean values, but I could add minimum and maximum or whatever. And then I just run that as well. It will create a new layer, and that will have my new values included. Oops, zeros. no problem. It's just the ocean, they are 0. So there are a lot of values here. Like that. So turn that off, turn that off. I only need to use work with this one. Let's see if it worked. Graduated, mean, and let's pick a color ramp. I've imported elevation. I need to change the mode. I think I can use natural breaks. Increase number of classes. Something like that. But I don't want a green ocean. So the easiest way I found is just to add a new stop on the color ramp and place it at 0.1% or something like that. Then I can change the starting color to maybe that. Yeah. So you have ocean color. This doesn't matter a bit because we are interested in 3D. So switch to the 3D properties for the layer and use a single symbol. And one problem I've had with the 3D in QGIS is that it renders really poorly. One way to minimize those render issues is to not use 0 as elevation. So just use anything above. Hello. And please make QGIS not crash. So anything above 0 is helpful. It will not eliminate every issue. And unfortunately, I'm pretty sure you will see some of my issues. I also changed the specular to black because I don't like it when it's all shiny. And the extrusion, I could select just the field, mean, but since it will hardly be noticed, I will use the expressions to build an expression that is larger. But I will still use the mean field, and I will multiply that by 50. So that will definitely show up. Let's start a 3D view. Control-Alt-M. Put that there. And now the curse begins. Trying to make this reasonably easy to view. Okay, now you see it at least. And if I rotate it, hopefully it won't be too glitchy. Actually, this one looks okay.
Yeah, it looks pretty cool.
Maybe we're in luck. So, colors.
It's like an optical illusion for me because I know it's coming out towards me, but it actually looks like it's going in. You know, I think it's just the way I'm looking at it.
Let me tempt the demo gods by turning on shadows. Nope, let's turn those off. It didn't work. Anyway, colors. The shading I'm using is this realistic Fong, and I don't think anything else will actually work. So the color to change is the diffuse color, and I will use the assistant for this. So select the mean for source of the values, update it, and then we will use the same elevation ramp and add a stop. Maybe like that, and that should be like that. And there we have
Stefan in the comments says, but QGIS never crashes.
yeah, right. Well, hard crashing has recently only occurred for me when I am working with 3D. So no, it's rarely, but unfortunately, I've been working a lot in 3D lately, so it has been crashing.
Of course, I did add the sarcastic tone to Stefan's comment.
Yeah. If you want to, you can add some edges to this. But that's a matter of preferences. So I like to have some edges. And if you're lucky, you can improve the look of this by turning on IDOM lighting, but maybe not this day. You could export it directly from the 3D view. Let's see. It actually looks okay. What I did, I used it to in a layout. So I just added layouts, 3D scene. Let's see here if I can get it to work. Copy settings from 3D view. I'm betting this will look horrific.
I'm holding thumbs that it looks all right.
But just by changing a little bit of the camera pose, it will switch back. So it looks reasonable, at least. There's some issues with anti-aliasing in this image on the screen. But when you export it in a higher DPI, it will look better. And here you can continue adding whatever. And my favorite thing to do when I do layouts in QGIS is to add HTML. Just bring that up in size a bit. Because then I can do stuff like better spacing. I can do shadows. Too much.
This so reminds me of those old school like 8-bit gaming images. We should make a little like game world like this.
Yeah, and you can play with CSS values as well. And I don't like that font. Yeah. Anyway, that's basically what I did to create this map, and it actually turned out reasonably well. And if I export it, it will be higher DPI than the directly exported image. So hopefully this will look a bit better. Yeah. So I think that looks okay.
That looks brilliant. I think that's great.
So you can play with the overall shape, the size of your extrusions. It doesn't have to be hex. You can do it with triangles and whatever. I was contemplating building a Minecraft world with squares. That would perhaps be.
I think that would be awesome.
Yeah. So that was it.
Very nice.
So that's brilliant. Thank you so much. I just my one question is there kind of like a minimum? I know because of the shapes of it that it may not matter, but is there like a minimum resolution for the DEM that you use? I know a lot of people will be using, just sort of general stuff that they can download, but is there any difference there? Does it make a difference?
As long as your pixels are not bigger than your shapes that you are generating, it will work just fine. When I did this the first time, I just sampled the value from the centroid of each hex polygon. So you can use whatever elevation data or statistical data you want. It doesn't have to be elevation data. You can symbolize statistics with this method. You have seen those, what is it, AreaLot, where you use a different software to extrude stuff in 3D. It's been
yes, I have seen some of those, even in the 30-day map challenge, actually.
Yeah, actually, and this could be an alternative to do the same within QGIS. So you can sample population statistics or anything actually, and just pick the statistics that you want to use, and then just extrude with that.
Alrighty, brilliant. So we have a couple of great comments. Hi, Raymond. And then I see that Javier also says hi. Map Serving says that they have a QGIS 8-bit t-shirt, which sounds awesome. I think we should make them using this manner in the future. I think it's Dusan says that you can also import external font styles, which would be really useful in the layout.
I can. When I was trying another map, I actually used Google's online fonts. I didn't even install them. I just included the CSS reference to that online font, and that works just fine in layout in QGIS. So you don't have to install the fonts if you don't have the right to do that. If you have access to internet, you can use any of the Google fonts online.
Fantastic. That's been just such a great tutorial. I can't wait to go and make one of Table Mountain, to be honest. That's my next stop after this video. So a whole bunch of claps and people saying hi, and thank you for that. I don't know, Victoria, if you have any comments.
I was wondering of how this this model will work in Blender to sort of smooth out the edges, sort of make them what's the right word? Rounder. I think it's more of like photoshopping the model, I guess.
Yeah, you can bevel it in Blender in a completely different way. I've only tried to export this kind of model once, and when I imported in the OBJ into Blender, it was without textures. So the MTL file didn't include any text or any information at all, so it was just the geometry, unfortunately. But I'm not sure if that was my system at the time or whatever, but the MTL file was completely empty, so no textures.
Awesome. I think that'll be our next step for another QGIS Open Day show. All right, so thank you so much, Klaus. I really, really enjoyed that. So we're now going to hop over to Hans, who's going to show us how to make the really cool map. I saw one come up on Twitter, and I immediately sent Hans a message and was like, "Oh, please, can you show us how to make this one?" So I'm really excited to see how he made this really cool 3D map. So over to you, Hans.
Thanks, Amy. Yeah, so it was already mentioned, AreaLot. So I will show some stuff in AreaLot in the end. Of course, we're going to prepare all the data in QGIS. And like Klas, we'll also start from just a DEM. So I have here a DEM. It's a SRTM. It has been reprojected to a UTM coordinate system and clipped to not make the calculation times too long. I think there's one step which takes 1.5 minutes. So Amy, good luck in filling that.
I'll sing us a song.
I reduced it from 3 minutes 30, so 1.5 should work well. Now it has the overhead of Jitsi, so let's see. And also pray that it doesn't crash, because with some of the walkthroughs in the newest version, it did randomly crash. I hope that doesn't happen, but I'll regularly save. So what we're going to use is the PC raster plugin. I've been talking about that also before, because we want to derive from this DEM the distance to rivers, not like in a Euclidean distance, but really the distance following the drainage, the flow direction. So the first step you always need to do if you install the PC raster plugin, well, there's 2 steps. We talked about it in last open day. This is a processing provider plugin. So you need to install the plugin, but also the software. So you can watch that back in the other video. But once you've done that, you also need to import your data to the PC raster format. Otherwise, you can't use these tools here. It's a GDAL format you can convert. So I have here DEM subset. And PC raster is picky on the data type for reasons that the tools check that data type and avoid that you're going to do things that you might not want to do. You can always overrule it. It has these different data types, and I'm going to use scalar, which means a continuous raster, which this is. And I save this. I was teaching before. Similar stuff. Just call this DEM and extension.map. That's what PC raster uses. And I have exactly the same data, but then in the PC raster format. And then the next step, what we will do in catchment delineation stuff and hydrology is filling the sinks. So there are all kinds of depressions here by collecting the DEM data that make the water stuck. So what we always need to do when we get a DEM and want to apply it for hydrology is to fill the sinks, and PC raster does it in 2 steps. So it's 2 steps at once with LDD create, and that's the step that takes 1.5 minutes, I hope. It will remove the sinks, and here you see in the manual that it does much more than other tools that were available. So you can determine how much water you need to add to fill the sink, where the outflow level is, etc., etc. But I keep those at maximum. Those are also the defaults in the tool. So we're going to fill all the sinks as much as possible. You'll see that it struggles a bit with the mines, open pit mines that need to be closed. And I call this flow direction. And now we need to sing a song. So what this will do is a heavy process iteratively and looking at speeding it up, because PC raster also supports using multi-core, but I don't know how to implement that yet in the QGIS tool. But basically what it does is now applying that algorithm. And then it ends up with a flow direction map, and flow direction maps have different encodings from different tools. So this one uses the numeric pad numbers. So you have, if you have a big keyboard in front of you, you can see arrows on them, and 8 is north, and 2 is south, and 4 is west, and 6 is east, etc. Well, Saga and GRASS and ArcGIS, they use different encodings. So always be aware how these directions are encoded. So why don't we store the degrees of compass directions in it? Well, probably that didn't fit in the past in 8 bits, so they encoded it. And also those directions are discrete. They're the so-called D8 8-direction method that we have in rasters. So if you go to a 3x3 window, you can only go in 8 directions, discrete directions. So that's probably the reason. Dum-ti-dum.
We need some elevator music.
Yeah.
Yeah,
or we can have plugins that take long to play some kind of tune.
We should call it sort of, in-between music. Why is it that they always play the worst music when you're on the phone and you're waiting for the next person to pick up? It's always some horrible music. Couldn't they just play something nice?
So definitely not that music. It did it. It took 1.5 minutes, so not much overhead from Jitsi on this tool.
Brilliant.
So we have here our flow directions in grayscale. There are all kinds of tutorials to change that to a directional color scale, which you in fact need for compass direction. So you cannot add a linear color ramp for these kind of things. What we need to do now is calculate the rivers. And we do that with the stream order tool from PC Raster. That will calculate the Strahler orders. That's a method to classify streams. Let's call it Strahler. And in raster algorithms, it basically means that we give every pixel Strahler order 1, follow the flow direction, and when 2 of order 1 join, it gets order 2. So if 2 of the same order join, it increases the order. If 2 of different order join, we don't increase the order. That's the method. And then you get these nice images out of that. We stay in grayscale this whole session because AreaLot needs grayscale. Or maybe there's one exception. So now I need the rivers. I don't need all the pixels here. So what I'm going to do is, with a threshold, going to determine the rivers. Normally you calibrate that with OpenStreetMap or a satellite image. So I'm going to get here all the pixels that are larger than stream order 8. I'll take 8 today. But normally you calibrate that. So I do that with conditional and Boolean operators. But it needs, let's say that's a comparison operator. So Strahler larger equal than 8, but it can only read maps. So we need to create a raster that only has value 8. And we can do that with the spatial tool. So with spatial, you can change a value to a data type in the PC raster format. So I need value 8. The stream orders are in ordinal scale because they're orders. That's a specific scale of PC raster. And I can use as a mask Strahler or flow deer or whatever. These masks are important because we work in the same raster dimensions. Otherwise, we can't work. And I just call this one ordinal 8. And I run it. And now all the pixels in this raster have value 8. And now I can do that condition. And I say Strahler larger equal ordinal 8. And that will be our river. And now we have our rivers. From people who know my courses, this is the Ruhr, the infamous or famous Ruhr River. And now I need an outlet. I'm going to hide all layers except the river. And I'm going to style this paletted unique values. Ordinal is also discrete, so we need to use this. Remove the zeros. And here I have the rivers. And then we can use OpenStreetMap as a background to see where the outlet is. Of course, below the rivers. And let's make it, this is the only exception here, red. So you can see them. And I want the outlet of the Ruhr. So here's the Ruhr. Why doesn't it match perfectly? Because we work with a model, we fill the sinks, there's urbanization, so it's not completely gravity flow. And I'm going to take an outflow point here, where the Ruhr roughly enters the Meuse River. So I click on a pixel here, right, and I copy the coordinate. I open Notepad to make a comma-separated file. Any text editor you can use, of course. Paste it. I add a comma, and I add value 1. If you want more outlets, just extend the comma-separated file. Here, I just use one outlet to have the Ruhr catchment. I save it, and we were working in the, I made a backup folder, of course, outlet. Just a CSV with the coordinates and an ID number. And then I can create a raster of that using data management and then column file to PC raster map. I open the CSV file. And here it is. And I use a mask layer. You can use river, they should all be the same. And I use here nominal. You can use Boolean or nominal, probably also ordinal. But if you have multiple outlets with different IDs, then your resulting catchment map will have then catchments with the nominal values. That's a bit the idea. In our case, we just have only value 1. So I call this, again, outlet, but now it's not a text file, but a raster map. Run, close, and here is our outlet pixel. And now I can derive the catchment. Search. And LDD means local drain direction. That's our flow direction map. They're all documented, and it also tells what kind of data types it accepts. Outlet is outlet, and then our catchment. Let's go. And there it is. I zoom to the layer, and here we have the Ruhr catchment, and here are some of these deep mines. And with this fill sinks algorithm, it creates a little sub-catchment inside the catchment. That's a bit different from if you use Saga or Grass, where that will not happen. If my students are watching, I hope you have noticed that. That it looks like a donut. Okay, then we can convert this to vector. Of course, in raster, conversion, polygonize. Take catchment, keep all the defaults, just do this quick and dirty. And then I save this to boundary. Okay, now we have a boundary. And I'll use that later. Let's go back to our LBD, our flow direction map that we have here, because we still need to calculate then the distance to the river. And we do that with a tool called LDB dist, this one. Friction distance from the cell under consideration to downstream nearest true cell. So we have the flow direction, but we still miss a layer. We have cells to which the distance is calculated. That's a Boolean, that's the river, but we miss the friction layer. If we make a raster with only values 1, it uses the cell size as the distance unit. So that's what I'm going to do. I use again this spatial function. And I just need a raster with only value 1, a scalar. At the mask, I can choose now flow direction. Let's call this friction. So by setting that to 1, I will have the distances in the correct map units. Otherwise, there's extra friction that we don't need. So I go back to LDD dist, should be here in the recent LDD dist. Okay, flow direction, river, friction, distance. And you get this beautiful map with distances to the river, to our Boolean river layer. And now we are going to prepare this for visualization in AreaLot. And what I want is to use an inverted polygon, which makes everything outside of the catchment black. So in AreaLot, black is the lowest and completely white is the highest. So that's what I'm going to do. Move to top. And I choose inverted polygon. And I want the outlet, the outside area to be just a simple black. I'm doing something wrong here. Oh yeah, classic. I need to edit this one because it still contains more than just the catchment. Students are thinking, yeah, you told us all the time and now you do it yourself. Okay, I'm gonna edit the attribute table. You see that because of the vectorization of the raster, there is some geometrical problems, some loops here. So we need to find out which is our catchment. Of course, value 1, this one. So I'm going to invert the selection and throw away the rest. And now it applies immediately, of course, the style. So now everything outside of the catchment is black. And inside it has the distances. Now, what I also want is that the rivers come out. So I make it white. If you want them a bit lower, you can make them gray, but let's just see what this does. And I could play with the color ramp, but it's already corrected. White is high and black is low here. But you can use different color stretchings to make it as you like. And I only need some places. Well, you've seen, I've missed it today, but I'll watch it back. Etienne's presentation, I guess it also covered quick OSM. Super nice. I'm going to add places. place, and I do here cities, and I want them as points. And never forget, you need to have then an extend. So let me just do canvas extend, and then I run it. It will download now the points with the cities in this area. Great. Over to the top, and just give it simple style, a dot. I don't want the stroke, so I change here to no pen, and I'm going to give it a label. And I wonder why it always goes to name Carnival. Sounds great, but I just I just use the name, the most name-looking name. Oh, it's a long list today. Here, name. And I'm going to make it white, so it pops out later. And I'm going to, you can change, of course, also the font, etc. Make it bold. So then this will also pop out of the screen later. And now I go to make a print layout. Wait, let me first save the project. Okay. Far so good. New print layout. And okay. And I just use entire paper. Oh wait, that is wrong. I don't want this. I want to make it portrait. Fits better with this size of the catchment in this case. Fill it. There it is. And it uses the extend, but I want it to fit a little bit better. I'm gonna, it's this. Yeah, it looks okay. And I'm gonna add a legend. Remove everything that I don't want. There's more down there. So we just have the distance, and let's go with the river. I don't need the band, and I'm going to change this to kilometers. But the numbers, I cannot modify that. Changing the units, that's not possible in these widgets, but I can then hard code it. So let's take 0 and 50. 0 and 50 kilometers. I'm going to change the width to 5 and the height to 50. And now I need to change a few more things. I don't want the background, and I want the fonts white, so it will pop out. So let's leave it like this. And on a 3D, you can include a north arrow, because you will turn it and then people will still see where the north is. So just a simple little north arrow here. That's all. And now we're ready to export this to a PNG. Yeah, let's call demo. Let's keep this also default. Save it. And now I can go to AreaLot, which is a free tool to render grayscale images as real voxels, which you can even export them to 3D programs like Blender. So you can double click here to open a grayscale picture that you want to render. So I go to QOD and to demo, and then I open it, and there it starts rendering. It shows here how far we are with rendering, and it's improving. And you can change a little bit the exaggeration here, 1.5. You can type it, or you can drag, typing a little bit more here. You can change the color to some light blue. Light colors work better than dark colors. And here you can change sun angle settings, a lot of other settings, but I'm just going to change the ground setting to make it a darker blue. Something like this. And yeah, there we are. So I could also render this again without the rivers. Then you would also see it. How's that?
Very, very cool. I love the 3D mapping things. It's amazing. So I have like a theoretical question. So all the rivers are kind of the same, I want to say height, on the 3D rendering.
Yeah.
Theoretically, is it possible, for example, if you had the depth of the river to show it in this kind of workflow, so that when you visualized it like this, it wouldn't all be the same height. You would sort of see the graduation in the depth of the river.
Yeah, there are several solutions to that. What you can play around with, you can calculate the flow accumulation. Then you have like the discharge. So it will start here upstream with smaller streams and accumulates downstream to larger ones, which makes it also look nice and realistic. I could have used the Strahler orders. So when we had that Boolean river, no river, I could also say then if there is river, give back the pixels with Strahler orders. That's quite easily done. And then you will get the different orders here and you can give them different heights. You could also use the new, let me say, what is the name of that one? There's a new styling option to get these tapered lines there. So you can also convert it to a line and then use a tapered buffered line, which will make, it's called the interpolated line renderer, which will interpolate over the length or over Strahler orders. So these are all kinds of nice varieties that you can use. You could also sample the Z value probably from the DEM and then do something with that. These are pixels, so that's quite easy. So you say, if there's a river, give me the DM value.
Awesome. All right, let me just check if there are any questions in the live chat. And I wanted to ask Victoria or Klaus if you have any other questions.
My first question is, what's the name of this software? It's like really cool. I've never seen it.
Okay, it's called AreaLot. And you can download it from free. If you Google this, then you can easily find it. It's a very simple installer and not a large file. And it's an executable that you just run.
It's a Windows only, I guess.
Yes, unfortunately, it is, as far as I know.
Oh, no.
Thank you.
I think it's open source, so maybe somebody wants to port this to Linux.
I think I know a couple of people who I can twist their arm. Alrighty, let's have a look. You have a couple of rounds of applause. One from Javier, just saying that this was great. And I do encourage any other questions to be asked, but your tutorial was very thorough. So I think everyone followed along really nicely. And yeah, I just think it's amazing to see the different approaches to 3D mapping and what you can do from the same basic input. Both of you started with a DEM and came to wildly different conclusions, which I think is amazing. And I think that's part of one of the strengths of QGIS. And I think it's awesome that you can really integrate it with other programs. I mean, several of us have been playing with Blender, and I think that's one of them that we've looked at. But thank you, Hans, for showing us the other options. The one thing I wanted to ask was, Klaus, you mentioned that you've been making some 3D little trees and models and stuff that you've saved. Could you show us where you've saved them and what they look like?
Yeah,
That
sure.
made me quite excited.
Let me just switch around my screens here a bit. Did I mute anything?
No, you're still with us.
Okay. There we go. Well, let me put my screen on. Yeah. So
I spy the TARDIS.
yeah. So oops. On this plugins.qgis.org. Oh, plugins. Org. On this site, you have all the plugins for QGIS, and you can search and read more about them. But there's also a hub. where we can share, anyone with a OSGeo login can share resources. So we have styles, entire projects, and those are for if you have something I know Tim he has made his dashboards as a project, and that includes a GeoPackage and the data and models and everything that you need to get it going. And then we have models, and those are the processing models. There's a few of them at least. And then the newest hub is 3D models. And it started with a few QGIS logos, but I thought this was so fun. So I started training myself on how to use Blender to create those trees here. And I even made a YouTube video about it. So
I saw it come out. It looked very, very cool. I've yet to watch it, but it's on my weekend list.
Yeah. And the nice thing about these styles are that you can preview them directly in the browser. It doesn't come out exactly as it would when you import them, but at least you get an idea of how the 3D geometry looked like. So
These would be amazing for those architectural drawings of developments and that sort of thing.
Yeah. So if I just download this model, because I don't have it on this computer. Switch back to QGIS. I'll do a new project. Add some data, so I have some form of scale reference. Let me throw in a tree here. So a point in a projected system like that. I'm planting a tree right there. And then we go to the 3D view and choose 3D model. And then I need to browse to my OBJ file I downloaded.
Do virtual trees give off virtual oxygen?
Exactly. I'm not sure what I called it now. Tree, perhaps? I need to switch back, see what it was called. Tree leaf autumn. Okay, it was a folder. Yeah, that makes sense because there's texture in it as well. A folder. Tree leaf autumn, and there's the OBJ file. Open it, and there it is. Let's switch to a 3D view. Now I think I will have some issues. And this is one of my peeves with 3D and QGIS. I don't find it very intuitive to browse or navigate.
It seems like quite a learning curve.
And some say it's easier in this first-person view, but you can switch that to terrain-based. It's, yeah, I'm not sure if it's that much better, but it makes more sense. And you start to see the tree there.
Oh, yes.
I don't know how I can move that. When you get really zoomed into QGIS in 3D, it really starts to be problematic. But let me try and fix it with terrain elevation. That might help.
And if you change the scaling on the right, does the tree then get bigger?
Yes, it does. So we can try that. Also, if I, well,
Oh wait, we've shot away from it.
We're lost. We need a map.
Is now a good time to mention I get motion sickness?
oh, it's bigger.
Oh, cute. Okay. I think these are fantastic.
Yeah, and one thing I found that when I was using is you can create models that are colored, but then you can change the colors. But since these are textured, if you just find the texture file, tree leaf autumn, there's a PNG. That's the texture. And if
Okay.
you open that in your favorite graphic software, and depending on the, oops, where did it go? There. I can change my tree to, I don't know, pink.
Yes, a pink
Like that.
tree. I love it.
And replace it, the texture file. Unfortunately, I need to reopen the OBJ, but then it's pink.
Oh wow.
So if you are not satisfied with the colors, you can play with that. And hopefully there will be a lot more 3D models here when people start to get into 3D modeling in Blender. And I started from scratch and made this yesterday. So it can be done if you just put some time into it. Not that hard.
Oh, that is awesome. I'm glad you've showed us this resource and where people can go. And definitely, if anyone who is currently watching our video has been inspired, definitely make a couple of 3D models or ideas in general and pop them up onto the sharing platform, because, you know, it's always great to be able to share stuff and incorporate them into the different maps. So that is very, very cool. The last comment is from Raymond, and it's for you, Hans. He says you could make the rivers transparent white to make them a bit higher than the plane that they're on.
Well, in AreaLot, you work with grayscale images, so you need to just choose a grayscale at the level that you want it.
Okay.
And yeah, maybe in QGIS. Sorry?
Couldn't you blend it with a background? So it's
you can, but in the end, of course, it needs to be in the correct grayscale position for AreaLot. AreaLot doesn't do anything with it; just reads the grayscale level.
All right. And yeah, that is our last question. I see Javier has to leave. Sad face. But he definitely wants more sessions like these. And I think these are my favorite kinds of sessions, the open sessions that are very interactive. I don't know, Victoria, if you have any last questions or comments?
I was wondering for the Blender objects, I remember there's a time I did a model and it wouldn't import the colors, I would guess what you call the textures in. So it always used to show up in a grayscale. I was wondering, what's the quickest fix you can think for that?
I'm not sure there is a fix. When Hans was doing his presentation, I opened the model I created in Blender. And the geometry is not suitable to process further and work with further. So the beveling of this geometry is not going to be easy because it's not a simple geometry. It's triangulated everything, and it's not really suitable to do anything with it inside Blender. And as I mentioned, the texture, it's just plain gone. I'm not sure if that's a bug or something in QGIS when it exports the model. But the coloring and so on should be in, I'm not sure where I put it. Yeah, there's an OBJ file, that's the geometry, and there's an MTL file that describes how it is supposed to look. And it also, in that file, it also references any texture file. But if it's plain simple coloring, it should be in the MTL file. And when you export from QGIS, the MTL file is just empty.
So we're definitely going to have to play with that one up and come up with a solution.
Yeah.
Yeah, if you want to process this type of data in Blender, there are ways that you can export your elevation rasters to Blender and then generate your hex shapes and extrude them and build useful shapes inside Blender. So if your end product will be inside Blender, I think you should start to do as much work as possible in Blender.
Klaus, did you try the mesh editor new functionality for these kind of things?
In Blender?
No, in QGIS, in the newest version.
No. I haven't tried mesh editor at all. I'm not sure what it is.
Yeah, for those of us not in the know, Hans, what's mesh editor?
Well, I read that there's a new functionality that you're able to edit meshes directly in QGIS, but I think for this it would be a lot of manual work, which does not make much sense, I think.
But isn't that mesh data? Is that the same as 3D geometries?
I'm not sure if it can read even this format, but I'm not so much into that.
Mm-hmm. I'm not certain it is the same thing.
Maybe not.
I'll have to track the person down who's been having a look at that, and they'll be in one of the next sessions.
Sounds good.
Alrighty. Thank you both so much. This has been such a fantastic session. I learned a lot, and I'm really keen to go and put those skills into practice. I see that there's a lot of clapping and likes from our video. Thank you so much to the audience for sticking with us and bearing with us today. I will have to let the community know as to whether there will be a open day at the end of the festive season, because I will be on holiday and probably somewhere that does not have signal on a mountain somewhere. So I will obviously let you know, put things out on Twitter and on the wiki page and on the community pages. So as I say, this is our final session of the day. So thank you all for joining us. Thank you so much, Hans and Klaus, for joining us and showing us and sharing your sensei-like wisdom. Thank you, Victoria, for being my backup. I always appreciate having someone there just in case I lose power or internet or anything like that. So thank you all for joining me. And that's it for today.
Thank you.
All right. Bye, everyone.
Have a nice weekend.